Okay, we'll start with number 1, parametric equations. So for parametric equations, first thing we need to do is graph it. So we're going to make a table with t, x, and y. So t, x, y. And for t, it looks like we can pretty much plug in anything we want. So we'll plug in a -2, a -1, a 0, a 1, and a 2. And when we plug -2 into the x equation, it looks like we're going to get a 12. And when we plug it in for the y equation, it looks like we'll get a -7. If we plug in a -1, we're going to get a 3 for x and a -1 for y. And then if we plug in a 0, we're going to get a 0 for x and a +1 for y. If I plug in a +1, I'm going to get a 3 and a -1. And if I plug in a +2, I'm going to get a 12 and a -7. So let's graph what's going on and do the orientation of the arrows. So we need our x's to go all the way out to 12, and then we need to go down to -7. And up to 1. So we have a point at -12, -7, so down here. We have a point at 3, -1. We have a point at 0, 1. And then we have the point at 3, -1 again. We repeat in 12, -7. So it looks like what's happening here is if I plug in a 3, I would get, let's see, 3 squared is 9 times 3 is 27. So I get a bigger x value, and I get a smaller y value. I would get -17. And if I plugged in a -3, I would just get the same thing again. So it looks like the smallest x value we're ever going to have is 0. And then the graph just kind of goes off in this direction. And it looks like it's a straight line. So for the orientation, we want to look at what the t's and the x's and the y's are doing. So it looks like that as our t's are getting bigger, our x's are getting bigger, and our y's are getting smaller. So we want our orientation to move in this way. Down, because that's the way that our graph is going to keep going. Okay, so now we need to turn these two parametric equations into a rectangular equation and state the restrictions for t, x, and y. So scooting over here, we want to solve for solve for t in terms of x. So we have x equals 3t squared. So first we'll divide by 3 and then take the square root. So we get t equals the square root of x over 3. And now we need to plug that in for y. So we have y equals 1 minus 2t squared. So we have 1 minus 2 times the square root of x over 3 squared. So that'll just be 1 minus 2 times x over 3. So it looks like we get the equation 1 minus 2/3 x, and that is just the equation of the line. Except we do have some restrictions. For t, we could plug in anything that we wanted. So there are no restrictions on t. We could just say that t is anything between infinity and -infinity. Except I don't need the equal to signs underneath. There we go. And then for x, it looked like we were only getting positive numbers, and they were all greater than or equal to 0. So we have x is greater than or equal to 0. And for our y's, if we scroll back over to the graph, The highest our y's went was 1, so the restriction for y is less than or equal to 1. Okay, for number 2, when we make our table, instead of using t, x, and y, we want to use theta, x, and y. And we want to plug things in for theta that are easy to work with, so we'll do 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. So when I plug in 0 for x, we have x equals 4 plus cosine theta. And let me just do the unit circle really quick so we can remember what all these things equal. So if we have 4 plus the cosine of 0, the cosine of 0 is 1, and 4 plus 1 is 5. So I'm going to get a 5 for my x value. And for y, we have negative 1 plus the sine of 0. So the sine of 0 is 0. So that'll just be a negative 1. For pi over 2, we have 4 plus the cosine of pi over 2, which is just 0. So 4 plus 0 is 4. The sine of pi over 2 is 1, so if we add a negative 1 to that, we'll get a 0. The cosine of pi is negative 1, so plus 4 would be a 3. And the sine of pi is 0, so with that'll be a negative 1. For 3 pi over 2, the cosine of 3 pi over 2 is 0, plus 4, 4. And then the sine is negative 1, so that'll be a negative 2. And then for 2 pi, we should be back to our original, 5, negative 1. So let's graph this and see what it turns out to be. So we have a point at 5, negative 1. We have a point at 4, 0. We have a point at 3, negative 1. And then a point at 4, negative 2. And then back to 5, negative 1. So it looks like we have this ellipse going on. And to show the orientation, we look at our thetas, and we're moving in the direction of the unit circle. And as you can see, our x values start at 5, move to 4, move to 3, back to 4, back to 5. So our orientation is going to look like so. Okay, so now we need to write our restrictions for theta, x, and y, and put our two parametric equations into a rectangular. So scrolling over here, we have x equals 4 plus cosine theta, so we're going to subtract 4 to the other side and just have x minus 4 equals cosine theta. And we will do the same. We'll add 1 to the other side and have y plus 1 equals sine theta. And now we're going to use the identity cosine squared theta plus sine squared theta equals 1. And we'll plug in an x minus 4 for cosine and a y plus 1 for sine. And it looks like here we have the equation of a circle, so we can stop. We're done. So actually we graphed a circle, not an ellipse. All right, the last thing we need to do is state our restrictions. So if we go back over to the table, our restrictions for theta should be between 0 and 2 pi. So theta is in between 0 and 2 pi. Our x's, look like they were in between 3 and 5. And our y's were in between -2 and 0. All right, moving on to our last one. This one we do not need to graph it, we just need to write it in rectangular form and then state the restrictions. So, first thing we need to do is isolate t in terms of x. So we will take the natural log of both sides, and we just get the natural log of x equals t. And now we are going to put that in for the t in the y equation. And we would like to cancel out the e in the natural log, but remember you can't do that until you move the 2 to the exponent of the x. So now we have y equals x squared as our rectangular equation. However, there are some restrictions on x and y. There are none on t. We can plug in negatives, we can plug in positives, we can plug in whenever. So t is just in between negative infinity and infinity. We will never get a negative answer for x. So x is going to be just greater than 0, because we still won't get a 0 if we're raising e to certain powers. And the same for y. Y will always be greater than 0.